The United States-Mexico border stretches for nearly 2,000 miles. It's a vast and varied landscape, sprawling deserts, winding rivers. This international boundary has a long and complex history. It was a line of cooperation. It was a line of conflict. For much of its existence, the border was largely open. Early efforts were small and localized, simple urban fences. Operation Gatekeeper in California was a major turning point. It involved erecting miles of fencing near San Diego. Early walls often used corrugated landing mats from the Vietnam War. Over time, the political conversation intensified. Calls for a more formidable, continuous wall grew louder. The debate: what kind of wall? The Secure Fence Act of 2006 authorized hundreds of miles of fencing. That led to different types of barriers across the border. Some were vehicle barriers, others were taller pedestrian fences. Materials and designs varied. This patchwork of fencing laid the groundwork for bigger projects. The discussion reached a fever pitch in recent years. The vision: an impenetrable concrete fortress, stretching from the Pacific Ocean to the Gulf of Mexico. But reality is far more complicated. A border wall serves a fundamental purpose. It's designed to control and monitor movement of people and goods across an international line. The primary goal is to impede and deny illegal entries. A physical barrier forces people to attempt crossings at official ports of entry. At those controlled points they can be screened and processed. The wall isn't an absolute stop, it's a tool to slow people down. That delay gives law enforcement, like the U.S. Border Patrol, crucial time to respond. Effectiveness is described as impedance and denial. Impedance means how long it takes to breach the barrier. A wall that takes several minutes or longer to cut through, climb over, tunnel under, that added time is critical. It lets sensors detect breaches and lets agents be dispatched to the location. A wall is part of a larger system: surveillance cameras and aerial drones. The barrier funnels traffic into tech-covered areas, making detection easier. Walls also deter smuggling of illicit goods. A formidable barrier makes that much harder and riskier. Ultimately, a border wall projects sovereign control. The wall is not a standalone solution. It's one component in a layered security strategy. When the discussion of a new comprehensive border wall began, the initial vision was often of a solid concrete structure. The idea was popular for its symbolic power. A concrete wall sounds strong, permanent, impenetrable. It evokes images of ancient fortresses. Modern marvels of engineering proponents argued that a solid wall would be the ultimate deterrent. It would be impossible to see through. However, border security experts and engineers quickly raised serious concerns. One of the biggest issues was visibility. A solid wall would create a massive blind spot. This could be dangerous. Agents would have no idea if people were gathering on the other side. It would make them vulnerable to attack. Assailants could throw rocks, projectiles, or even open fire from the Mexican side. Another major drawback is vulnerability to breaching. Concrete can be defeated with the right tools: jackhammers, concrete saws, explosives, which could create a hole. The dream of a solid concrete wall began to crumble under practical reality. To find the best design, the federal government commissioned a series of prototypes. In 2017, 8 different models were constructed side by side in the desert near San Diego. This was a real-world test. The prototypes were intended to be a proving ground for different materials and designs. 4 of the prototypes were made from reinforced concrete. The other 4 were made from alternate materials, primarily steel. Each stood about 30 feet tall. They were imposing structures, a tangible display of the competing visions for the future of border security. The prototypes underwent rigorous testing. Military special forces were brought in to try and defeat them. They used sledgehammers, they used power saws, they used torches, they used climbing gear. The goal was to see how long it took to breach each design. The results of these tests were closely guarded. However, officials later stated that every single one of the prototypes could be breached. The steel designs generally performed very well in these tests. Specifically, the steel bollard design proved to be a formidable obstacle. Bollards are tall, vertical posts. They're typically filled with concrete. They're spaced a few inches apart, wide enough to see through but too narrow for a person to squeeze between. Based on the performance of the prototypes and extensive feedback from Border Patrol agents, a clear preference emerged. The steel bollard design was selected as the standard for all new wall construction. Building a wall across nearly 2,000 miles of border is an enormous and expensive undertaking. The cost of materials is one of the most significant factors in the total budget. When comparing steel and concrete, the financial calculations become, well, pretty complex. Initially, one might assume that concrete is cheaper. It's a common construction material used worldwide. However, for a project of this scale, The logistics of producing and transporting massive quantities of concrete to remote border locations present a huge challenge. This drives up the overall price significantly. Steel, while sometimes more expensive per unit, offers advantages in manufacturing and installation that can lower the total project cost. Steel bollards can be mass-produced in factories to uniform specifications. This industrial process is highly efficient. The finished bollards can then be transported to construction sites along the border. Concrete, on the other hand, would either need to be trucked in as precast panels or mixed on site. Mixing concrete in remote desert areas with limited access to water is honestly a logistical nightmare. These panels are incredibly heavy. They require heavy-duty cranes and specialized equipment to lift and set them in place. Building the access roads needed to get this heavy equipment to rugged, remote border locations adds another massive layer of expense. Steel panels, while also heavy, are generally lighter than their solid concrete counterparts. The streamlined logistics of a steel-based system ultimately make it more cost-effective for a large-scale linear project like a border wall. The single most important reason for choosing steel over solid concrete is transparency. The ability for Border Patrol agents to see through the wall is a critical tactical advantage. Patrolling the border is a dangerous job. Agents often work alone. A solid concrete wall would create what's called a fatal funnel, basically a blind spot where threats could gather undetected. An agent approaching the wall would have no idea what or who was waiting on the other side. This lack of situational awareness puts law enforcement lives at unacceptable risk. The steel bollard design directly addresses this issue. The bollards are spaced approximately 4 inches apart. That gap is narrow enough to prevent a person from passing through, but wide enough for agents to have a clear line of sight into Mexico. They can see if people are approaching the wall. They can see if someone is attempting to stage an assault. They can see if someone is attempting to throw projectiles. This transparency lets agents anticipate threats and react proactively. It turns the wall from a blind barrier into a screen, security plus surveillance. This see-through capability is also crucial for preventing what agents call rocking incidents. In areas with solid fencing, it's common for individuals on the Mexican side to throw projectiles over the wall at passing Border Patrol vehicles or agents on foot. With a steel bollard wall, agents can see the person throwing the objects. The transparency itself acts as a deterrent. Assailants know they can be seen and are more likely to be held accountable. The US-Mexico border traverses some of the most challenging and environmentally sensitive terrain in North America. Rugged mountains, deep canyons, shifting desert sands, flood-prone river plains. Building any structure here is difficult, but a solid concrete wall presents unique environmental and logistical problems. One major issue is water drainage. During monsoon seasons, powerful flash floods can rush through desert washes. A solid concrete wall would act like a dam, blocking these natural flows. This could cause catastrophic flooding on the upstream side. The steel bollard design helps mitigate this problem. The gaps between the bollards are too small for people. They do allow water to pass through. They also let small animals pass through. Logistics in remote areas also favor steel construction. Many parts of the border are far from major roads or cities. Building new access roads to support concrete trucks and heavy cranes is a massive, environmentally destructive and expensive endeavor. Those roads would cut scars across the landscape, disrupting habitats. Steel components are generally lighter and more modular, so they can be transported and installed with less intensive infrastructure. In very remote, mountainous areas, panels have even been flown into place by helicopter. The wall must go up and down steep hills and conform to uneven ground. The flexibility and relative ease of installation make steel a far more practical choice for the wild and unpredictable borderlands. The choice of steel for the US-Mexico border wall was not an arbitrary one. It was the result of extensive testing, practical experience, careful consideration of numerous factors. While a solid concrete wall held symbolic power, it was rejected as impractical, unsafe, and costly. The decision was pragmatic, focused on what best serves border security on the ground. Steel, specifically the steel bollard design, emerged as superior across key metrics: security, cost, environmental impact. The most critical factor, the safety of Border Patrol agents. A see-through wall is non-negotiable for modern enforcement. Agents must maintain situational awareness, spot threats from distance, and avoid ambush. A solid concrete wall would create dangerous blind spots. Bollards give a formidable barrier while preserving transparency. Logistics and finances also favored steel. Panels can be mass-produced in a factory then transported to remote sites, far easier than massive on-site concrete pours. Lower long-term maintenance makes steel more fiscally responsible over decades. The design also helps the environment. It allows water drainage and reduces construction footprint in sensitive habitats. In short, the steel bollard wall balances strength and strategy. Tall enough to be hard to climb, strong enough to slow breaches, transparent enough to be safe to patrol. The truth, it wasn't shocking, it was logical and evidence-based.